Today we are going to discuss about minimum cost spanning tree using Prim's algorithm. To find minimum cost spanning tree using Prim's algorithm, first of all we should know what is a graph, what is spanning tree and what is minimum cost spanning tree. Graph. Graph is a collection of vertices and edges where each edge has specific weight or cost. Say there is a graph, it is having some nodes and there are some vertices and every vertex is having some weight or cost. Then spanning tree. Spanning tree is a subgraph that connects all vertices of the original graph without forming any cycle. See the second figure, MST of graph, minimum cost spanning tree of graph. So of course it is a spanning tree where it is not having any cycle. It contains all vertices. It contains all vertices and it is having only subset of edges. It is having all the vertices that the original graph contains, but it is having only subset of edges, but all the vertices are connected. The graph is a connected graph. Then minimum cost spanning tree. Minimum cost spanning tree is a spanning tree where the total sum of weights of all the edges is minimized. You may get any number of spanning trees, so many number of spanning trees from a graph based on the number of vertices and edges. Out of all these spanning trees, we are going to find the minimum cost spanning tree means the total sum of all the edges is minimum. That is said to be a minimum cost spanning tree. Then a minimum cost spanning tree must satisfy three distinct rules. All nodes covered. So this is a figure shows the minimum cost spanning tree. It contains all vertices or nodes. All vertices are nodes. Where graph contains 7 vertices, here also it contains 7 vertices. Then second one, there are no cycles. It cannot contain any closed loop or circuit. No cycle. Here also there is no cycle. Then the third one is minimal total cost. The sum of all weights of edges used must be lowest possible out of all possible spanning trees. There may be so many spanning trees. Out of all the spanning trees, the sum of all the weights is minimum in here. So which is said to be minimum cost spanning tree or MST. Minimum cost spanning tree or MST. Now, how to find a minimum cost spanning tree from a given tree? There are some different possibilities using Prim's algorithm, using Kruskal's algorithm. Now we are going to discuss about finding minimum cost spanning tree using Prim's algorithm. Using Prim's algorithm. Prim's algorithm is a greedy algorithm used to find minimum cost spanning tree of a weighted, undirected, connected graph. See here, it is a graph. It is having some 7 nodes. It is an undirected graph. It is a connected graph. It is weighted graph. Weighted graph means every edge contains some weight or cost. It builds the tree incrementally by starting from an arbitrary node and repeatedly adding the shortest edge that connects the tree to a new unvisited node, avoiding cycles. So we should find the minimum cost spanning tree where the minimum cost spanning tree contains all the vertices and a subset of edges, and it should not form any cycle. The total cost of or the total weight of edges selected should be minimum. Then it is said to be minimum cost spanning tree. The algorithm is as follows. Let G is a connected graph. Say this is G. G is a connected graph. Then let the minimum cost spanning tree be null. Initialize with minimum cost spanning tree as null. So minimum cost spanning tree. We are going to find minimum cost spanning tree. Initially it is null. Initially it is null. Empty tree. Say empty tree. Stage by stage you add one edge or one node using some edge. Then select minimum cost edge from the graph. See here in this the minimum cost edge is 10 with weight 10. So which connects 1 and 6. So node 1, node 6, the edge is with weight 10. Then add this minimum cost edge to minimum cost spanning tree. Initially minimum cost spanning tree is selected as empty tree. Now we have added one edge. Then find all edges from the graph which can be connected to the minimum cost spanning tree. So now this is the minimum cost spanning tree which contains two vertices, one edge, and if there is any possibility of adding another edge, yes, there is a possibility of adding 1, 2 or 6, 5. 1, 2 contains weight 28 and 6, 5 contains weight 25. So 25 is minimum. So add 6, 5. Add the edge with the weight 25 to the minimum cost spanning tree. So I'm going to add 5 with weight 25. Now repeat steps 5 and 6 till all vertices are added. So again find the edge that can be connected. How many edges you can connect? You can connect 1, 2, that is 28. Then you can connect 5, 7 with 24 and 5, 4 with 22, in which 22 is the smallest value. 22 weight is with the help of edge 5, 4. So add 4. Add node 4. The weight of edge is 22. And again repeat till you complete all, you add all the vertices. Only 4 vertices have been added, still 3 more vertices we need to add. Again find what are the edges that can be connected to the minimum cost spanning tree from the original graph. Now there is a possibility of adding 24 7 with weight 24, then uh, then 7 with weight 18, then 3 with weight 12. So you can connect 4 3 or 4 7 or 5 7 or 1 2. 1 2 with weight 28. Out of this 4, 12 is small. 12 with the help of adding edge 3. So add vertex 3. So add vertex 3. The weight is 12. Now repeat again. Repeat 5 and 6. Now find what are the vertices that can be connected to this minimum cost spanning tree. So there is a possibility of adding 1 2, 1 2 with weight 28, 1 2 with weight 28, then 5 7 with weight 24, then 4 7 with weight 18, then 3 2 with weight 16. These are the 4 different. Out of these 4, 16 is the smallest value with the help of 2. So add vertex 2 and the edge with 16. Now repeat. Try to find what are the other vertices that can be connected to this minimum cost spanning tree. So now you can connect 1 2, 1 2 with weight 28, 1 2 you can connect, but if you connect 1 2 it forms a cycle, so you cannot add. Then 2 7 with weight 14, 2 7 with weight 14, then 5 7 with weight 24, then 4 7 4 7 with weight 18. So these are the 4. So 28 is already ruled out. Then 14, 24, 18. 14 is smallest. 14 we can connect. So 14 is with the help of by adding vertex 7 to 2. So 14, 7 is added here. There are no other vertices to be added. All the 7 edges vertices have been added. So the sum of weights of all the edges 10 plus 25 plus 22 plus 12 plus 16 plus 14 would be the minimum cost spanning tree. So this is the spanning tree which formed by selecting the minimum edges. Finally, this may be the minimum cost spanning tree where the minimum cost is 5 to 7, 7 to 9, 9, 6, 15, 15, 4, 19, 1, 2, 3, 4, 6, 8, 9. 99 is the total cost of minimum cost spanning tree, weight of minimum cost spanning tree, which may be said treated as MST, minimum cost spanning tree of the given graph. In this way, we can find the minimum cost spanning tree. For clarity, it was given here minimum cost spanning tree, minimum cost spanning tree of the original graph, where it contains all the vertices, all vertices. It is not having any cycle, no cycle, and the sum of weights is minimum. Sum of weights is minimum comparing to all other spanning trees. You can find any number of spanning trees out of the spanning trees. So this is the minimum cost spanning tree. Minimum cost spanning tree means the sum of weights of edges is smaller, minimum comparing to any minimum any spanning tree. Thank you.